Good morning, good afternoon, good evening. This is Mr. Payne bringing you Unit 6A, Lesson 1 and 2. This short little mini unit is one of my favorites to teach. It's talking about sequences. We're going to talk about two famous sequences, and that's arithmetic and geometric sequences. All of these are very easy and nicely done if you remember to create a table for each one to keep your things organized. So I'm going to show you briefly and quickly on how to talk about setting up your table and dealing with your sequences and some key vocabulary for this mini unit. A sequence is a very special, very special type of function. When students first encounter sequences, they often think of them as just a list of numbers in some particular order, and then they have to find the pattern. We will start with technical definition of a sequence in terms of a function. A sequence is a function whose set of inputs, the domain, is a subset of natural numbers, example 1, 2, 3, 4. A sequence is often shown as an ordered list of numbers called terms or elements of the sequence. Sequence function notation can be tricky, and yes it can, but I'm going to give you a little suggestion on how to make it a little less tricky. We just said that it is a function whose set of inputs, the domain, is a subset of natural numbers. So we're missing my domain right here. So let's add in my domain. So if you want to take and add in an x and a y just like that, my x is my domain, don't forget. And it's a subset of 1, 2, 3, 4. We're not starting with 0 with my table. So that's 1, 2, 3, 4, 5, 6, 7. And you read these by saying a sub 1 is 4, a sub 2 is 8, a sub 3, a sub 4, a sub 5, a sub 6, and a sub 7. I want you to just really pay attention. Did we start with 0 here? No. In the next video, I will show you that we can extend that table over here to 0 once we figure out my pattern and we start talking about patterns, and that'll help you write an explicit formula. But today, we're just talking about patterns and being able to recognize the vocabulary and find things that we need. So, question A says find a sub 3. I'm going to come on over here to a sub 3, and what is it? I hope you can tell me that it's 16. Then we're going to find a sub 1, which is, I hope you can say, is 4, plus a sub 7, which is 256, and I'm going to add those together because that's what it says to do, and I'm going to get 260. Then it says find a sub 2, which is 8. A sub 1 squared. I hope that you can identify that a sub 1 is 4. So I'm going to take 4 and I'm going to square it, which gives me 16. Find a sub 5 minus a sub 4. A sub 5 is 64, minus a sub 4, which is 32, which gives me an answer of 32. Now, F is the tricky one, and I hope when you remember back to Unit 3, that a sub n right here, when I see that a sub n, I told you to remember that you can say that it's y equals 128. That makes that question a whole lot easier. When I go over to my y and I can go to 128, and I can say, oh, it's under the 6, so that must mean that it's a sub 6. It's my 6th term, so a sub 6. And I really hope that you can pay attention to the notations and how I'm reading it. Do you see how this is read? A sub 3. It's the same way as this guy being written as this, a sub 2. So it doesn't matter how it's written, it means the same thing. A sub 3, a sub 2. It's asking you to find the second term, a sub 2. All right, we're going to continue moving on and talking about sequences that are functions. And the key here is that the input is simply the numbers of place in line, so to speak, and the output is the actual number in the list. Consider the sequence defined by the formula. Here's my function formula, 2n plus 1. Write out the first 5 elements of the sequence. One of the things that I need you to focus immediately on is what it's the direction and how many terms they're asking you to write. In this case, it says the first 5 elements, first 5 terms. So the first thing I'm going to have you do, always in this chapter, is create a table. 1, 2, 3, 4, 5. And all you have to do is take my input and plug it in. Okay, and don't forget my x is my n. I'm going to take my 1 and plug it in. Take my 1 and plug it right into here. 2 times 1 is 2, plus 1 is 3. 2 times 2 is 4, plus 1 is 5. 3 times 2 is 6, plus 1 is 7. 4 times 2 is 8, plus 1 is 9. 5 plus 2 is 10, plus 1 is 11. One of the things that I want you to really pay attention to, in the next one, it says, now graph the sequence grid shown below. Remember that this is my barrier. It wants you to graph from 1 to 5 on my x-axis. Remember that my x is n in this case. So that's all I'm going to do is I'm going to go to 1 to 3, over 1, up 3. To 5. Ooh, I put that in the wrong place, which is just fine. I can erase that real quick. 2, 5. 3, 7. And so forth. You are not going to connect these points. It says, why should we not connect the points plotted in the continuous straight line? We're not plotting these points, or we're not graphing these points, because if you notice here, okay, I'm not asking for 1.5. I'm not asking for these in-between terms. So I can just use this as just a simple points, because this does not determine what these in-between points are looking for, or what these in-between points are going to be. So I want us just to pay attention to that and make sure that we know that we are not in this chapter connecting these points together. Okay? All right, let's continue to C, or D, I'm sorry. What is the 21st term of the sequence? Show how you arrive to your answer. So if I'm looking for the 21st term, all I'm doing is taking my 21st term and plugging it in for n, because remember, n stands for term. So I'm going to say 2 times 21 plus 1. 2 times 21 is 42, plus 1 is 43. We're going to flip over now to Unit 6A, Lesson 2 sheet of paper. We're going to talk about sequences can be defined by a classic function formula, like what we saw in exercise number 2. And they also can be defined recursively. Ooh, that's a real new word right now, so I want you to take out your pen, your highlighters or your pencils and underline the word recursively. And we're going to talk about the recursive formula, and I'm going to show you a real easy way to remember what we're talking about recursive formula and what is needed. So the word recursive, we use that prefix re all the time. We talk about rewind, repeat, redo. Those are all prefixes. We've had to done something before we can redo it, right? We had to watch something before we can rewind it, or something had to play before we can rewind it. So it always depends on what happened first, and that's what it says here. It depends on a term or terms that came before it. So recursive, when you remember recursive, think of that prefix re and what that means and how we use it on a day-to-day basis. So consider a sequence of numbers given by the following definition. B sub 1 equals 7, and B sub I equals B sub I minus 1 plus 4. Well, a couple of really important parts in here. You need to always state the first term when we're writing something recursively. The other thing that's important is that we put the word and in there, and then we write our statement of B sub I. Now, how do I know it's recursive? Is because of this little term right in here, the I minus 1. It could be N minus 1, B minus 1, whatever our letter is that's determining our terms, it's going to be minus 1. That is a telltale sign that it is a recursive formula. So that B minus 1 or that I minus 1, when it's in that subset like that, okay, it's recursive. Okay. So now it says A, give a common sense interpretation for this recursive formula. So, well, in this case it says, we know that when it's recursive, it means a term before it. So, a common sense interpretation is the term before it plus 4. Pretty easy, right? All right, now we're going to get to the B. And we're going to talk about this, and I'm going to show you how to set it up and stay organized. Write out the rule for the first 4 terms. Well, remember, I told you to always highlight. How many terms does it want? 4 terms. Good. So what are we going to do? Whenever it says that, in order to say organized, we're going to say, all right, here's my x, here's my y, and I'm going to go out 4 terms. 1, 2, 3, 4. And it tells me that b sub 1 right here is 7. So I already got part of my formula written in there. All right. Well, now we're going to do some language work here. B sub I. Remember that my x is my I. So here's my I. Right? We just call it x just to keep things organized. B sub I. What B sub I am I looking for right now? What's the next one? I already know 1, so what am I going to look for? B sub 2. So that B sub 2 is going to go every time I see I, right? So B sub 2, I know this is the first time you're seeing this, so stay with me. B sub 2 equals B sub 2 minus 1 plus 4. Noticing that B sub 2 minus 1, that's smaller, right? Okay, so let's do that. What is B sub 2 minus 1? B sub 2 equals B sub 1 plus 4. All right, now let's look at our table. What is B sub 1? B sub 1, and you should be able to look right into my table, is 7. I take that 7 and I plug it right in for B sub 1. So B sub 2 equals 7 plus 4. What is 7 plus 4? Well, I hope you can tell me that that's 11. Voila. I found out what B sub 2 is. B sub 2 is 11. Now let's try B sub 3, because it's my third term that I'm looking for. I'm going to change colors just so you can stick with me here. B sub 3 equals B sub 3 minus 1 plus 4. Okay, let's do that B sub 3 minus 1. B sub 3 equals, what is 3 minus 1? It's 2. B sub 2 plus 4. All right, let's go back to my table. What is B sub 2? I'm hoping that you can tell me that it's 11. So B sub 3 equals 11 plus 4, which gives me 15. One more marker change here. I'm going to go to brown. Let's stay organized for B sub 4 now. We're looking for B sub 4. I'm just going to move over to my left-hand side where I have more room. B sub 4 equals B sub 4 minus 1 plus 4. What is B sub 4 minus 1? Well, it's B sub 3 plus 4. What is B sub 3? Well, we know it's 15 now, plus 4. B sub 4 equals 19. Now, there's a couple ways that you can check this. Well, the first thing I want to do is talk about how I know it's the recursive formula. Notice that I had to have the term before it in order to find the next term. Once I knew I had 15, then I can use 15 to find 19. Well, you should say, hey, Mr. Payne, I know back from when we're talking in Chapter 4 about my linear functions, in that if I have a plus 4 pattern, I know it's plus 4 there, and plus 4 there. That's where this plus 4 comes in. Once I know that first term in a recursive type formula, this plus 4, or this statement here, is how I am changing my table. So I'm increasing each term by 4. Hopefully that makes sense. Sequences often show up in real world, where they are sometimes defined in terms of recursive process. Kirk is trying to train for a marathon. His first month he runs 5 miles per workout. He adds an additional 3 miles to his workout for each month. I hope everybody underlined or circled the word adds. He adds an additional 3 miles to his workout for each month he trains. Fill out the table below for the amount of miles he runs as a function of how many months he has been running. So I hope you know that we're going to add 3 each time. So 5 plus 3 is 8. 8 plus 3 is 11. 11 plus 3 is 14. 14 plus 3 is 17. What I want to do right away so that you have an example coming into class so that we can do this is I want to write a recursive definition. So let's remember, what do I need for a recursive definition? I need my first term. So we're going to write a sub 1, which means first term, equals 5. The word and a sub m, because that's what we're using here, that's where I got it from, a sub m equals, now the key, a sub m minus 1. Remember, I'm going to highlight that in red for you right now, that this m minus 1, that's huge. That tells me that it's going to be recursive. And what is my pattern? What is my pattern? We're going to what? What did we do each time? We added 3. So a sub m minus 1 plus 3. And that's going to be my recursive formula. Now go ahead and you plot your points here. 1, 5. Now don't forget that we're not going up here. Watch my scale. So 1, 5. I'm going over by 1s on my x, but I'm counting up by 2. So 1, 5 is going to be 2, 4. It's going to be right up in here somewhere. Okay? Then we're going to go to 2, 8. 2, 4, 6, 8. Then we're going to go to 3, 11. And then we're going to go to 4, 14. 2, 4, 6, 8, 10, 12, 14. And then the last one is 5, 17. 10, 12, 14. And those are my benchmark points, and those are my points, and you should have a nice graph there. If you have any questions, please write them down. I expect you to fill out the WSQ for both of these, 6A1, Lesson 1, and 6A Lesson 2. Thank you very much, and have a great evening.